Hi, I'm Sid. I'm the Vice President of FRC 2013, and on behalf of 2013, this is our entry into the KLA Creativity Award, and we're going to be presenting a slideshow about our Power Cell shooter. So, a little bit of background on our robot. We called it Doom Turtle, and it was our best robot to date. It was capable of a quick climb, it had an efficient intake, a fast-feeding magazine that could hold 5 balls, and it had a quick-firing shooter to top it all off. So we started off with priorities before we did anything else. Before we prototyped, we set down some guidelines, and it followed. We didn't want to make a turret as it was too complex for us at the time, and we had never made a shooter before, so we wanted to keep it simple. We wanted to consistently hit the inner port under ideal conditions, namely when the ball was not damaged, and it should have the range for a shoot from anywhere of the field forward of the control panel to give us flexibility. It should also be vision assisted. We then moved on to prototyping, so the main decision we had to make was between linear and hooded shooters, and we constructed prototypes of both, as you can see on the right. The hooded shooter turned out to be accurate due to the induced backspin, and it had an easy manipulation of the exit angle of the ball due to the adjustable hood. The linear shooter, on the other hand, was faster, but it had relatively inaccurate trajectories, and adjusting for different targeted distances would be much harder, so we decided on a hooded shooter. Design. We catted the design in Onshape that consisted of 2 aluminum side plates, 2 Falcon motors driving 2 4-inch rubber wheels via a 2-3 belt abduction, and we got around 8,000 RPM max. We had a fully adjustable hood that could go from anywhere between 15 to 70 degrees of exit angle for the ball. It was driven by a single Neo 550, and it had 3D printed sector gears to move it up and down along bearings, and we had a 3D printed mount for the limelight. It was coplanar, so we didn't have to mess with any offset calculations. We had a few hiccups along the way. For example, the polycarbonate backing that we used turned out to be brittle when mixed with that epoxy, and it experienced catastrophic failure. The hood mechanism wasn't toleranced very well, and we used 3D printed parts where we should have used aluminum, so it led to a lot of play during max extension, and it wasn't very accurate. The shooter could not fire at a high rate because it didn't have the rotational inertia to do so. And the Spark Max motor controllers gave us a lot of issues in that it would randomly decide to re-zero the hood when it should not have been zeroed, and that would lead it to try to move forward past its physical max extension point and strip the belt that drove it. However, we addressed this very quickly before CVR. We replaced the polycarbonate sheet with aluminum sheet, and it was much stronger, and we used bolts instead of epoxy, which was much better. We used the hood mechanism was remachined, and we used aluminum instead of 3D printed rails, and that made it much more sturdy, and you could barely notice any play afterwards. We added some 4-inch steel inertia discs on the sides of the wheels, courtesy of a local team, 1351 TKO, and that allowed us to shoot very fast due to the increased rotational inertia, and we added a physical limit switch so that we could manually re-zero the hood should it decide to re-zero itself during a competition, and thus we had a failsafe. Vision. So the way we tackled vision was we used a limelight system that was on the shooter to calculate the X offset from the target and get the distance. Using the X offset, it could align itself with the press of a button, and using some data points that we got by manually adjusting the hood and getting the limelight angles for each RPM value, 3 of which we used. We had 3 functions that would take in a limelight angle and spit out a rev encoder value that we could use to get the correct hood value for that distance. And what we ended up with was a very nice system that could shoot from anywhere on the field from a single press of a button. So in terms of performance, we ended up with a pretty accurate shooter, and I would like to say that we're pretty proud of this, especially considering it was our first time making something of this sort, and it enabled us to do something like this 6-ball auto.
I'm initializing 6-ball.
Well, that concludes my presentation. Thank you for listening, and I hope you enjoyed.